Hi. So, okay, today I'm going to be going over asymptotes, which is a pretty simple concept, but has some rules that need to be fully defined so that I can easily recognize them on the exam and in the future. So, when looking at something like this, right, a function like this, starting off with the vertical asymptote is always the easiest for me. So, vertical asymptote is when the denominator equals 0. So this needs to equal 0. But first, before that, we actually need to factor it out because right now you can just say, oh, -3 and +3 are both vertical asymptotes. But if you factor this out and you're able to cancel something out, then that's not true, and you'll get it wrong. So if we factor this out first, we get x minus the x plus 3. Oh, okay, no. X minus 3, x minus 1 over x minus 3, x plus 3. And cancel out x minus 3, leaving us with x minus 1 over x plus 3. So this shows us the vertical asymptote is actually only -3 instead of -3 and 3 because this is our function. Oops. Okay, so vertical asymptote's pretty easy. Now, horizontal asymptotes is when it has some rules that we need to pay attention to. So with horizontal asymptotes, we have to see that we have to look at the exponent of each of the leading coefficients here. So when we're in a situation where the here, we'll just write it out. So the numerator exponent, and then numerator exponent, denominator exponent. When the numerator exponent is greater than the denominator exponent, say x over 2 or x to the second power over x to the first power, this means that there is no horizontal asymptote, that it doesn't exist, that there's no horizontal asymptote and you don't have to worry about it at all. So if you see something like this, or 3 over 2, anything like that, means there's no horizontal asymptote. So what does it mean when it's the opposite? So the numerator is less than the denominator. In that situation, this means that, I'll just write this out. In this situation, it will always mean that the horizontal asymptote equals 0, no matter what, regardless. In a situation where x to the second is below the leading coefficient, that's what it's going to be. It's going to be 0. But when they are equal, like our situation that we have right now with the 2 and the 2, both leading coefficients, you just take the leading coefficient, 1 over 1 in this case, and you get your horizontal asymptote. So our horizontal asymptote here is 1. Now with slant asymptotes, we have a similar set of rules. Well, not similar, but just to see if it exists or not. So a slant asymptote only exists in a situation when the numerator exponent is less than, is greater than the denominator asymptote. This would be a situation like x squared plus 1 over x minus 2. This would mean there's a slant asymptote in here. If it's reversed, no slant asymptote. This is the only case it'll ever have a slant asymptote, is when the numerator exponent is greater. You see, in our situation, they're equal, so we actually have no slant asymptote at all. So let's do a problem really quickly that actually has a slant asymptote, just to practice. So f of x equals x squared plus 3x plus 5 over x plus 1. And as we can see here, the exponent of the numerator is higher than the exponent here, 2 over 1. So to find the asymptote here, we can factor this as well, just to check if we can cancel out the denominator. And this is x plus 5, or x plus 5, and then x minus 2. And that's not the denominator, so we can't do that. And to get the actual asymptote, the slant asymptote here, you have to do polynomial long division. So in this situation, we'll do x squared plus 3x plus 5 divided by x plus 1. Okay, here is something that was gone over a while ago. So x going into x squared is x, and then 1 plus x is, I'm forgetting how to do long division. X going into x is x, and then times 1, or times x times x times x, x squared, and then x times that is plus x. So now we do this, and this is 0. This is 2x, and then we bring down the 5, so plus 5. So now we have 2x plus 5. X goes into 2x 2 times, so x plus 2. And then 2, so this is 0. And this is 3. So we have a remainder of 3. We're going to find out if that's right. Yeah, so our answer is x plus 2 plus 3 over x plus 1. And the slant asymptote in this situation would be x plus 2, right here, the answer that we got from dividing. Yeah, and that's going to be the answer. So that's how you find slant asymptotes. A little bit more complicated, but also just the same. So the things I just got to remember are, when finding a horizontal asymptote, if the numerator is greater than, then it doesn't exist, right? I'm checking if I'm correct here. If the numerator is greater than, yeah, it doesn't exist. And if the numerator is less than, so if it's bottom heavy, it's going to be 0. And then with this, if it's bottom heavy, then that means there's a slant asymptote. So that's pretty much all I really need to know for asymptotes. And I think that's enough for the exam, and just enough for asymptotes in general. So